These diagrams are helpful to draw out what's happening in a molecule with regards to what's bonding to what, where the electrons go, and what's the relative energy. In this case, in our example, we're going to draw an MO diagram for an F2. Now you could draw the Lewis structure for it if you wanted. F2 would just have a single bond with 3 pairs of electrons on each fluorine. That's the Lewis diagram. We're drawing the MO diagram. How do you do that? In the center of the diagram, you're going to put the molecular orbitals. So you see I have the molecule here. On each edge of the diagram, you're going to have the atoms, and thus the atomic orbitals. So you see the fluorines on the outside. So we're almost imagining as if the fluorines are flying together and bonding in the center of the diagram. You'll see the vertical or y-axis is energy. So as you go up the scale, as you go up the page, you're going up in energy. So how do you draw a diagram for F2? First you focus on the fluorines individually. Electron configuration of 1s2, 2s2, 2p5. You'll want to write that out first. And it's the same for both. And then what you want to do is draw each of these orbitals. So you see I wrote a 1s, a 2s, and a 2p. Remember, is that each bond has 2 parts. The bonding part and the anti-bonding part. So, and I recommend for our class, you look at each set of orbitals separately, starting with the lowest energy one and making your way up. So what you're going to do is for each bond, these 1s orbitals are going to come together and bond. They're going to make a low energy and a high energy bond. So you put a line for the bonding part and a line for the anti-bonding. Remember, this will constitute essentially one bond between the 1s orbitals. And then you connect the molecular orbital with the atomic orbitals, and you beautify it by putting these dashed lines. And that shows where the molecular orbital came from. Then you're going to do the same for the 2s orbital. The 2s orbital is going to form a bonding and an anti-bonding orbital. So the bonding is always lower energy, the anti-bonding is higher energy. And then you're going to beautify this with dashes to show where the molecular orbital came from. Finally, for the 2p set of orbitals, again you're going to have bonding and anti-bonding. However, you're going to have bonding and anti-bonding for a total of 6. That means there's going to be 3 low energy ones and 3 high energy ones. In lecture I'm going to spend more detail explaining where these come from. But for now, since we're just learning it, the basics here, I'm going to draw what it would look like. Again, you're going to learn this pattern, why this pattern is so in lecture. But it'll follow this pattern where you have the bonding molecular orbitals down here and the anti-bonding up there. And then you connect them with dots like this, or dashes, just so you can see where those orbitals came from. All of these molecular orbitals come from the 2p atomic orbitals. When you see a single line all by itself, here and here, those are what are called sigma bonds. So notice I'm putting a sigma next to all these single lines. When you see 2 lines like this, those are pi bonds. Okay? Now, for the subscript of each of these, you're going to put the subscript, where the subscript will be the name of the atomic orbital it just came from. So these 2 are 1s, because they were formed from 1s orbitals. These 2 are 2s, because they're formed from 2s orbitals. And then the top 4 all have subscripts of 2p, because they come from 2p atomic orbitals. And then there's also a superscript to look at. All the anti-bonding ones, or the ones at high energy, have a superscript of a star. So of these 2, I'll put a higher one gets a star, these 2, higher one gets a star, and of these 6, these higher ones get stars. First consider the atomic orbitals. It's 1s2, that means there's 2 electrons in the 1s. 2s2, 2 electrons in the 2s, and then 2p5. 1, 2, 3, 4, 5. When you go to the other side, it's going to be the same thing. I recommend you look at each part of the diagram separately, and you start to go from the bottom to the top. Let's start with a 1s. The 1s, each atom contributes 2, for a total of 4 electrons, and you fill it in like this. 1, 2, 3, 4. Then look at the 2s. Each atom contributes 2 for a total of 4. So in the middle, we're going to have 4. 1, 2, 3, 4. For the 2p part of the diagram at the very top, each atom contributes 5. So we're going to have a total of 10 that we fill in the middle. It fills in a very specific way, so follow along with my pen so you see how this works. 1, 2, 3, and then stays unpaired, 4, and then pairs, 5, 6. Number 7's up here, 7, then 8, unpaired over there, and then 9, and then 10. And there we go. There's the MO diagram for F2.